Hello and welcome to Hadoop Exam Learning Resources. Today I am going to announce that our new training about Amazon Web Service networking in depth. In this training, we are having hands-on session as well as concept-based training. So what you have to do, you just go to hadoopexam.com. This is our home page. Click on the Amazon Web Service here on this link. And in this you would go over here. So this is the link for this networking training. You click over here. This page would be launched. So this training is useful not only for network specialty exam, but there are other certification which very frequently ask networking related questions. So one of the example is Amazon Web Service Solution Architect, whether it's an associate level or professional level. Almost 30% question you would see in the certification exam which are based on the networking. Then AWS Security Specialty, how would you make your network secure? So as part of this training, we would be learning all this concept. So there are total 19 concept based module and as well as 8 sub project hands-on session. Okay, so this is we would be covering. So this is the entire syllabus of this training which we are covering. So you can see we have in between project as well. So there are 8 sub projects we have created as part of this training. So you can get the downloadable PDF which we are using as part of this training, as well as the access to the material to do the hands-on exercises for the Amazon Web Service. So let's start the module and then we will discuss about the further thing later on at the end of this session. Okay, so I'm stopping now and starting the training. Hello and welcome to AWS Networking in-depth training. So in this module, we would be covering the IPv4, IPv6 and Cider Notation. So let me start with this first and then we'll go through. These concepts are very important to learn because in almost each module, upcoming module, we would be using this concept. So this is very important. If you already know, then still I would recommend you go once with this module. So IPv4, so you know, like this IPv4, it's well known, correct? So we can represent our IPv4 in the 4 block as seen over here, correct? So this is, and each one block represent 8-bit. Okay, so 8-bit means this binary data, correct? So this is a binary data. So there are total 32-bit we can use to represent our IPv4 address. So how does this work actually? If I would say my 4-bit, so this is 0.0.0.0. This is one IP address, correct? Now up to how many number it can goes, this first 8-bit represent, so up to 2 raised to power 8, which is equal to 256, correct? So because we are starting from 0, so then it should be 0 to 255. That is the possibility. So my maximum possible IP address would be 255 here. Second would be 255 as well. Third one is 255. And this is 255. So this is my minimum possible IP address using 32-bit, and this is the maximum possible IP address using the 32-bit, correct? So that is what we would be using over here. So now, so this is the possible range which we have discussed. Total possible IP addresses in IPv4 is around 4.29 billion distinct IP addresses you can have in the IPv4. How many? 4.3 billion. So now there are challenges with the IPv4. Everybody knows, like these IPs are not enough for our distinct devices we have currently, correct? Now if you see, we have a mobile devices, we have our various websites, we have our IoT devices. We cannot assign each and every device an distinct IP address out of 4.3 billion IP addresses, which create a problem because this is a limited. This is not enough to like have so many IP addresses for every device. So we need to have some way of work around so that even my I have limited IP addresses, I can still assign some IP to identify this device. Okay, so we would be discussing this later on, but in IPv4 it is also possible. You can even having a limited IP addresses, but you can assign it to more than 4.3 billion this IP addresses. But this is a problem. Obviously there are some work around to do this, but this is not a final solution. So what exactly next is, these are all IP address even out of this 4.3 billion, correct? So this is 4.3 billion IP address. Not all the IPs we can use it. Okay, not all the IPs we can use it. Some of the IPs are reserved for some particular purposes. Okay, and creating private network, like the purpose, like creating a private network. which we would be discussing. This is one of the important topic across modules in this training. So private network. So some IP is reserved for the creating the private network. So 4.3 billion, some goes for the private network. Creating public network accesses. So we need to create a public network. So like some website wanted to have a public IP address, and that should be static. So this kind of requirement also there. So this is the another way where we reserve the public IP addresses. And there are other purposes like broadcasting, looping IP addresses, and this were a lot of IP addresses already been consumed or reserved for some purposes. So even you are not getting a 4.3 billion IPs which is available. So there are far fewer IP addresses which are usable. IPv4 is limited, as we have discussed, correct? So now what is the workaround for this? So as a nowadays even IPv6 is being used for this thing. So what exactly IPv6 is? IPv6 is 128-bit. And my IPv4 was 32-bit. So now IP range, it was giving me 4.3 billion IPs, but this is like trillions of possible IPs it is giving it. And this is so high number, we can never consume all this IP addresses. Even we are using all mobile devices, all IoT devices, everything, whatever we use it, even consuming this so many IP addresses, like how many? 2 raised to power 128 IP addresses we can create it, correct? So this is huge number, trillions of IP addresses. This is also known as undecillion number, much larger than IPv4. So notation, how would you refer this IPv6 notation? Is like, this is again a 16-bit, like we have seen, this is the block of 8 blocks into 16-bit. So which brings to 128. Okay, so this is my hexadecimal number. Okay, this is what hexadecimal number we would be using. So in the dot, then this actually IPv6 is represented separated using the colon rather than this dot notation. Okay, so this is the difference. So these are the 8 blocks. So here in this example you can see this is 2001. This is another, this way we have represented 8 block. Each one is a 16-bit IP address. Okay, here you can see. Now we need to shorten this IP address representation, because writing so big string all the time is not comfortable everybody. So they wanted to shorten it, and it is so how we can shorten it? If there are all the bits which is 0 in my IPv4 address, we can represent them using the single 0. So here you can see all leading 0, not only all 0, any leading 0 we can skip it. Okay, here, so here in this IP, how many leading 0? 3 zeros are leading, here 3 zeros are leading, here 3 zeros are leading, here 2 zeros are leading. So we would be removing this, and this you can see this is 2001, only leading zeros we would be removing here and creating the IPv6 address like this. Still it's a big number, we wanted to shorten it. If we see consecutive zeros in my IPv6, we should be removing it and representing using the double colon here. So you can see this is the double colon which is represent the consecutive numbers, 0 consecutive numbers in the IPv6. Okay, so this is how we shorten this IPv6 string. Here you can see this is way. So we have 8 block, we should have 8 block in my IPv6. So but here 1 2 3 4 and 5 blocks. So between this 2 colon we found it, it means this is a consecutive zeros of 3 block is present here. That is what my algorithm needs to find it out. In AWS we would be having IPv4 and IPv6 both, and okay, so most of the time you may not deal with IPv6, but there are possible option available to use both IPv4 and IPv6. We would be using many of the places during the training IPv6 as well. Each individual device can have so many IP addresses. Okay, so my individual now number of IPs is so high, like it is possible IoT devices, my mobile devices, whatever websites I do have, everything can have a single unique IP address globally, which is not possible with the IPv4, but with IPv6 it is possible to globally unique public IP address. I'm specifically saying public, not a private. Public IP address for IPv6 is possible for every unique device globally. Okay, so we would discuss about private and public later on, little later. Okay, so now Cider notation, classless interdomain routing. So this is, you need to certainly understand if you are going to work on the networking. Okay, so this is very important things you should understand. There are many places in AWS we have to specify range of IP addresses. So Cider notation help us in defining the IP range. IP range can have a single IP address, or it could be a as more than one IP addresses in the range. So this is the notation is known as a Cider notation. Okay, so you need to understand what exactly this. So this, if you see, this is represent your range of IP. How does it define the range of IP? So here you can see this is your actual IP address, which is separated by a backslash, okay, with a 16 forward slash. This is a 16-bit number. Okay, this is 16-bit, which should be frozen. So here you can see my 32-bit. What we say, like my first 16-bit leading 16-bit should be frozen. 8 plus 8, this should be frozen, and after that whatever is there, my IP can change it. Okay, so now let me tell you how does this work exactly. So this is my IP address 10.0.0.0/16, correct? So I am saying my 16 leading bit. So this is my 16 leading bit should be frozen. It cannot change, but this 2 IP can change, correct? So what I would do here to my first IP 10.0 and start with this. My next possible last IP would be what? I said this cannot change. The 10.0.0 this would remain, but 0 to up to 255 it can go. So 255, this is also can go up to 255. So my IP range here is what exactly? Up to 250. This is the so many IP addresses in this range. How would you calculate the number of IPs in this range? Because we have total 32 bits, so always minus this number from 32, then you would get the number of IPs. So 32 minus 16 is my 16, and which is 2 raised to power 16 sorry, distinct possible IP addresses in this range. So how do you represent your range in the Cider notation? Here by slash, and which the values after the slash represent the frozen bit. Let's take another example here. Okay, so this is, let's say, 10 raised 0 0 0 and 0/24. If I say, what does that mean here? 24 means 888. So 3 octet, or you can say 24 first bit. So this is my 24 first bits which needs to be frozen, and remaining IPs can, remaining octet can change here. So how many IPs we can have here maximum? You can say 10.0.0. This is a frozen, but this is can go up to 255. Correct. So this is my initial IP and this is my last IP in the range here with 24 if I say here, correct? So how many IPs, distinct possible IPs in this range? 2 raised to power 32 minus 24, which is equal to 2 raised to power 8, which gives me 256 IPs. So even you can see here this 0 to 255 distinct values. So you can see there are 256 different IP address. Now let's calculate another range so you can understand 10.0.0.0/28. Okay, now this is a 28 bits. So this is 24 bits and 4 bits from this octet, correct, is frozen. So how would you calculate this actually? So I can say 32 minus 28 equals to what you can say 4. So 2 raised to power 4 is actually 16 distinct IPs are possible. So it can go up to 10.0.0.15. That is inch here 10 raised to power 10.0.0.15. Okay, so now this way we would be creating. Why we would be creating so many IP ranges? Because when we in AWS, when we go for creating the VPC subnets NACL, NSCL, Network Access Control List Security Group, we always providing the range of IP address. Is it possible to write, like, suppose let's say my IP is 10.0.0.0/24, which represent almost how many IP addresses? 2 raised to power whatever 8, correct? 256 IP addresses. So is it possible to write each and every IP address and then use it? No, it is not possible. So here in VPC, subnet, NSCL, security groups, whenever we create this, we provide this syntax, Cider notation, to provide the range of IP. So now you would have understand what exactly I mean by range of IP. We can use Cider for that. So represent leading bits here, which we have already discussed here. Okay, so I'll not go this. So 2 raised to power 16, this is 65,536, memorize it, 65,536. Okay, because this, why I'm saying this, there is a reason for that. Okay, so however, all these IP addresses may not be usable. Now we are saying in this range 10.0.0.0/16, we are getting 65,536 IP, but all this IP again may not be usable. Okay, which you remember here. Why? I'll again tell you little later. So still quite a good range, but it is a good range for like creating, like in my network I can have more than 65,000 computers, correct, or devices in the network if I use this range. So this is a good amount of the system. So don't worry. So 24 to 55 frozen. Okay, so this is what we have discussed, correct? Largest range in AWS VPC. Okay, so now you need to remember virtual private cloud, which we are going to discuss in more detail later on, but these are the logically separated private network in the AWS. Okay, so this network you can create with the maximum possible IP range /16. Okay, it means your one network in AWS can have maximum 65,500 machines approximately in each network. So what you want, if you any organization who want more than 65,000 systems in their network, so how can they work? So they can simply create more VPC. So if I need like 1 lakh system, okay, in my network, so what I would do, I would create 2 VPC and use this. So this would give me, so this way you can have even more systems in VPC, and that is doable. So number of systems are limited in one network, but across the network it can increases. So smallest range in VPC, this is the maximum possible range. You can create 65,536 IPs, which is maximum possible, and minimum possible is 16 IPs. And always remember, memorize for certification purpose, 5 IPs in from one network is always reserved by AWS, okay, Amazon Web Services. So if in your smallest range there are 16 IPs, so out of 16 IPs, 5 IPs Amazon would reserve for their own use. So you would have only 11 IPs available. So if you create a network with the /28 IP ranges, you can have 11 system in that network, not more than that, because the 5 IPs goes to the Amazon Web Service and remaining 11 IPs you can use it, okay, in that network. So this is what you have to remember. So thanks a lot. I hope you understand the Cider notation, IPv4 and IPv6. This is very critical things to learn, okay. So thanks, and I hope you like this session. If you're watching on YouTube, don't forget to subscribe it. We are providing more such session on YouTube as well, okay. So these are actually from our full length training session, so you can go to hadoopexam.com. so this is our website, okay. So this, you can see, this is our website, hadoopexam.com. there you can just click on the Amazon Web Service, AWS, and you can see all the content related to Amazon Web Service, okay, here. So these are all currently available products. Almost 11 products are available for the Amazon Web Service, which is including your certification preparation material as well as training. We are going to introduce the projects as well as soon as possible. So please keep visiting hadoopexam.com to get to know more about this stuff. Thank you. I'm stopping now. So now you have seen our first module from the AWS networking training. Similar session we have created for this training, so you can go through all this session and you can learn about the in-depth concept about the networking. And there are various products like which include as part of our premium subscription as well. So you can just click on the this premium subscription button, and you can see this is like various subscription model also we are coming up. Like people wanted to access more than one product kind of thing, and they wanted to have some limited time access or kind of thing. So these are the various subscription model we have created, which is more affordable and more material would be accessed. You just click on this and you can start learning on the stuff. So this is our certification preparation material. This is our project which we are just going to launch by tomorrow onwards. So this is the project about Amazon Web Service. So the entire project would be created over here and you can access this project. And these are the various on-demand training you can see here. These are the ebooks which we are launching. We have already launched it, and you can just click over here and you can start learning. Click on it, it would be launched in a separate page. Similarly, interview preparation. This is very critical part for the people who wanted to grow in their career or looking for the job or something kind of thing. So various interview questions. So these are not 10-20 interview questions we are providing. We have creating entire ebook for preparing for the interview, and this ebook may include audio question and answer as well. Like this book, you can see this include video come audio book as well in this. Similarly for Cassandra. So these are interview preparation material we are also including. So interview preparation material does not include only interview question and answer. The other stuff may be like explaining how to appear in interview, what HR question would be asking kind of thing. This thing also we would be including as part of this material. So go through this entire material. I hope this would be helpful for you. Thanks for watching, and I hope you like this all stuff. And please help us providing your feedback as well at hadoopexam@gmail.com. You can send an email, any of this email ID. And if you have any questions, then please drop an email. Or if your team in your company, you want to make your team to be learn this stuff like cloud computing, big data, machine learning, data science. So these are all the product listed on this page. You can check this page, and if you have any question, drop us an email. If you want to subscribe in the group, so you can drop an email. We would provide some discount kind of thing, or various organization already building their team with using this product. So this would help us to help you to like build a team working environment kind of thing. So you could have your perpetual license as well for this subscription. So thanks, I'm stopping now.